My name is Jose Collazo. I come from Hidronav Technologies. First of all, I would like to thank the organizers of the webinar, both for organizing it and for inviting us. Our company, Hidronav Technologies, is a highly technological company that is founded in 1994. We are from Spain, from a city that is called Vigo, which is an important fishing port, and that's the reason, the main focus of our company is marine technology. But apart from this branch, we have another one that is the development of experimental technology for research projects. And in this branch, we build design technology for different sectors. We've done things for the forestry sector, for natural stone studies, for ultrasound research, and so on. The base of the company is marine technology, and basically the origins are or were as a reseller of major brands of marine technology and to provide technical services. So now we have long experience in such marine systems, and we have provided technical service around the world. Our company provides a broad range of technologies like navigational systems, radars, but we are particularly strong in ultrasound systems. We also are experts in satellite communications. So we work very closely with satellite companies, so we can tailor very well our services to the needs of the project. Apart from this, we do developments of experimental technologies. We have a small but quite strong research and development department. Some of the developments are related to marine technology, of course. For instance, we design and build custom ultrasound systems. In this case, I'm presenting an advanced amplifier that works from 0 Hertz to 15 megahertz that can provide an output of 2 kilowatts working in continuous wave. And it's a Class D amplifier, so it's very efficient. Like I put there, it's like 98% efficiency at 2 megahertz with a 1 kilowatt output, but it's more efficient at lower frequencies. Some pictures of the systems, like we've worked for this project that uses high intensity focus ultrasound, like 8 megahertz and so on. We also designed some sonotrodes and did some work in metamaterials for focusing ultrasounds. Then I would like to present other areas of R&D for presenting the capabilities of our company. At the moment, our key technology are next generation cosmic ray detectors. These are particle detectors. That is technology derived from particle accelerator detectors. And what we have done is to refine this technology, industrialize it, maintaining really high performance, but making it fit for industrial applications. Among our projects are in particle physics and astrophysics, but also we are very interested in space weather, like geomagnetic storms and this kind of sun-related phenomena. On weather and climate applications, and that's like really important for us. It's one of our main focus now. And also muon tomography, which is making inspection of bigger structures or mountains using cosmic ray radiation. We have developed electronics for particle accelerators. So we developed front-end electronics for the forward experiments in a particle accelerator in Germany. We also have developed front-end electronics for an Antarctic telescope that is currently installed in Antarctica. We have also software capabilities, so we are developing a digital infrastructure with a pilot inside a big European project. We develop prototypes for spare weather prediction. One of our biggest projects is a muon tomography project for inspecting cargo containers. They are passive scanners using cosmic ray radiation. And our current project is the Stratos project, that is a system to study the stratosphere indirectly by measuring the fluxes of cosmic rays on the ground. So this is really interesting because we can build detectors that we could be in the future deploy, for instance, in the oceans. So you can monitor the state of the atmosphere and the stratosphere in a way that is not possible right now. At the moment, it's done partly by satellites, but they have many limitations. So what is broadly used are stratospheric balloons, and that cannot be deployed in the middle of the ocean. All of this is possible because we have a really good team. So we have like a long experience technicians. We have very good electronic engineers. We have PhD physicists and like very highly experienced software developers. And recently we also have mechanical engineers for designing. Usually we did that with our companies, but now we have also this capability. We can develop like physical simulations. We have a broad range of capabilities. The future for us would be to create some spin-off companies of the particular applications that may be interesting for doing so. We would like both to focus on industrial research and development, meaning to get to practical industrial applications of our developments, but also we like exotic research. So maybe, I don't know, we'll try to go into acoustic telescopes that are being developed now that they are underwater, and things like metamaterials, as I said before, for focusing or shaping the beams of ultrasound. We get our funding, research funding from regional, national, and European entities as Horizon 2020. We have not a lot, but some experience in Horizon 2020. Got SME instrument phase 1 and phase 3. And we are working now with our infra project. And that's all. Thank you very much. I put there a picture of when the European Commission invited us to a fair in Chile, and another picture of the flag of Hidronav in Antarctica, which is really cool. And that's all. Thank you very much.
Thank you, Jose. Now it's short time for questions. I don't see any question yet, but later on, if anyone from participants would like to put in contact with Jose and ask him about the technologies which Hidronav has, we are of course happy to connect you. I have just one question, because you have mentioned that you are in the future you are interested in developing industrial R&D projects. We do have among participants quite a lot of R&D centers, so I just want to ask you if you have any particular ideas in mind, or is more open invitation for collaboration?
No, it's definitely an open invitation. One key technology would be these ultrasound amplifiers, for instance, that we've developed, and they've been only used for research projects. So they have been one-off prototypes, and this is an example where we would like for this technology to find other applications, more broad applications. Maybe they are research applications, but we would like it to be like not one-off prototypes kind of thing. That's an example of that.
Okay. We do have one question here. Which kind of detectors are you using for cosmic ray detection?
Yeah, we are using two technologies, but the one we are more interested is resistive plate chambers, which is technology that has a very high temporal resolution, and it can be completely customized. So it's built completely by us, so we can design completely the performance of this system. So that's the main system, the main technology, RPCs it's called.
Okay, we have another question, and this will be the last one to ask. Which applications are you developing in relation to weather and climate?
Yeah, the Stratos project, it's basically is to develop a new instrumentation which can monitor the state of the atmosphere in real time. The first application is to have a profile, a continuous profile of the temperature, and specifically the temperature of the stratosphere, and this done in a continuous manner. So you can monitor in a continuous fashion instead of as it is done now that they fly balloons. So maximum you get 2 measurements of the temperature of the, like the profile and the stratosphere. You get 2 measurements per day, so you cannot analyze faster dynamics and stuff like that. So our objective is this continuous monitoring of the temperature profile and stratospheric temperature with a new instrumentation.
Okay, so thank you very much, Jose, for your presentation and for your answers. As I said before, if anyone has more questions, please drop them into the chat, and then we will follow those questions to Jose later on.